Okay, it's Earth Science again. Okay, today we're going to talk about metamorphic rocks some more. The first thing we're going to do is this bell work about explaining the 4 types of metamorphism. You should know that we did talk about this yesterday, and I made a video yesterday, and the computer died halfway through, so now we're going to talk about it again. Skylar, what's one of the 4 types of metamorphism?
Okay. One of the 4 types of metamorphism is impact metamorphism.
Okay, yeah, we'll start with the most exciting one. Impact metamorphism, right? So all these end with metamorphism. Impact metamorphism, and what happens in impact metamorphism?
It's when a meteor impacts Earth's surface or a rock.
Right. And then the reason it's metamorphism is because it changes the rocks, right, via what 2 methods? What 2 things cause metamorphism? Heat and pressure. Heat and pressure. Heat and pressure make a rock metamorphose, is the verb we use. But it can't be so hot as to do what?
No.
Melt, right? So the rock that isn't melted but is exposed to heat and pressure becomes a metamorphic rock. And one way is through impact metamorphism. What's another way? Colby?
The way is
We did it yesterday.
regional.
Regional. What happens in regional metamorphism, Natalie?
It's when with the tectonic plates.
Right, when there's tectonic plate motion, and that causes an enormous amount of heat and pressure on a whole region, which is why we call it regional. Maddie, what's another type? That's okay.
Did you say hydrothermal?
We haven't yet, but we're about to. Hydrothermal. Explain hydrothermal to me.
I only have a high temperature water. But
Yeah, it's caused by high temperature water. So when water gets extremely hot, right? First of all, even though the water is extremely hot, we would expect it to be a gas, but it doesn't because the pressure is so high too. And that's true for many of these things. So one thing is that many times these rocks do get hot enough that they would melt if they were on Earth's surface. But since they're below the surface and the pressure is so high, it keeps them in a solid state, and that makes. Come on, we'll cut it. I'm sure you can cut it. I'm sure, or I'll just tell me the answer.
it's okay.
It isn't really, but thank you for saying so. Contact metamorphism, and explain contact metamorphism, girl.
So when a meteor hits Earth's surface.
I think you're thinking of impact. That was impact. Contact is different. When is contacting what?
Oh, when it is exposed to
When it's exposed to magma, right? When it's exposed to magma. So when there's and we had this little drawing yesterday. When there's a magma pocket, magma should be orange. Magma. Remember this?
Mm-hmm.
And then the rock that's around it that doesn't quite melt. This is where the contact metamorphism occurred. There's a special name, kind of like, I don't know, not slang, but like an unofficial word for that. What is it? You remember? Someone better.
Baked rock.
Baked rock. Yep. Oh, baked rock. Okay, so those are the ways that metamorphism occurs, and these all form what thing? What broad thing are we talking about today? Metamorphic rocks. And so the objective is we're going to categorize metamorphic rocks today. Nice. Things are going great this time. Well, other than some things are going great. Some things are going greater than others. Okay, we'll leave it saying Earth Science. I think this looks nice. I don't care what you say. Okay, so we're talking about the different types of metamorphic rocks now. And there are 2 broad types of metamorphic rocks. Two broad categories. That's how you spell categories of metamorphic. I think I have to hit it that hard so it makes such a loud noise. Probably not, but I can't help it. 2 broad categories of metamorphic rocks. The 2 broad categories of metamorphic rock are foliated and non-foliated. What word that you've heard that especially kind of applies this time of year does this word remind you of? Or is there one? Does this word remind you of anything? Have you ever seen this word or anything like it before?
Exfoliated.
Okay, yeah, exfoliated. What does exfoliation mean? It's just something here on the commercial.
You exfoliate your skin.
Yeah. Exfoliate is to remove the top layer of your skin, right? In little. Have you ever heard of the word foliage?
Yeah.
Yeah. What's foliage? Like if we were going to go look at, like we did in our field trip, if we go look at the beautiful autumn foliage, what are we looking at? The leaves. Yeah, this word is from a Latin word that means leaves, right? So when you exfoliate your skin, you're removing leaves of dead skin, which is kind of gross. But also, when there's foliage outside, we're talking about the leaves. And this word is, these are called foliated and non-foliated rocks because the foliated ones look like little piles of leaves. They have layers. So the foliated ones, and it's different from, we'll see in a second, but it's different from the kind of layers that we see in sedimentary rocks. So these ones have layers or what we sometimes call banding, which implies that the non-foliated ones probably what?
Don't have layers.
Yeah, no layers or banding. And then within the foliated rocks, there's a special, kind of sequence of foliated metamorphic rocks that can form. Look with me on page 146. For the foliated metamorphic rocks, we talk about increasing grades of metamorphism. And all this means is that, oh goodness, I've run out of room, that's a long word. Higher grades of metamorphism going down. Okay, so we're going to start with the lowest grades of metamorphism, and we're going to go to the highest grade of metamorphism. And all this means in grades of metamorphism is that the rocks have been exposed to more heat and pressure. Okay.
Lower to higher.
Yeah, we're going from lower to higher. So from the lowest grades of metamorphism to the highest.
And this is just for foliated?
Just for foliated, yeah. The grades of metamorphism does apply to non-foliated, but we're going to be specifically talking about foliated ones and their relationship with the grades of metamorphism first. So first of all, I'm not going to write it up here because it's not a kind of metamorphic rock, but do you remember the kind of sedimentary rock that we talked about that had those little layers in it? It was made of clay particles and it looked like little layers. Oh, you said shale. Shale. The word's pronounced shale, but yeah. So shale had those little layers in it. When that is exposed to even a little bit of heat and pressure, well, it's still quite a bit. But when it's exposed to the least heat and pressure, it becomes something called slate. And you've heard of slate. I know you have. Oops. I almost put an R at the end of that. And then I erased everything. Where have you heard of slate before? There's some back there. You can't see it on the camera, but that's slate. The chalkboard is slate. You might have, they're kind of old-fashioned now, but you could have, your house could be shingled with slate shingles. But it's a flat metamorphic rock, very smooth. When the slate is further exposed to heat and pressure, it becomes something called phyllite. And when that is further exposed to heat and pressure, it becomes something called schist. And when that is further exposed to heat and pressure, it becomes gneiss. So as we increase heat and pressure on, this doesn't just happen to shale, it's any kind of layered sedimentary rock. It first becomes slate, then phyllite, then schist.
So going
then gneiss.
down, you're going higher. So you're going
Yes.
from low to high, not from high to low.
Exactly. From low to high, as we said. So slate has the lowest grade of metamorphism, then phyllite, then schist, then gneiss. And so why would it be important to know about this? Like, what can we do with this information? If we're out looking at rocks, if we're out exploring the environment and we find some rocks, what does it tell us if we find, for instance, a piece of schist? That at one time, we're not going to go down a mile to find a piece of schist. We're not going to be digging around that deep. But if we just find a piece of schist lying on the ground, what does that tell us about that area?
That it would have had high pressure.
Yeah, at one time, where that rock is now, that place was exposed to extremely high heat and pressure, right? And then before that, it was a sedimentary environment. Okay, some examples of metamorphic rock, and I'll in a second I'm going to pause the video and then go get some rocks to show you these ones. But first, let's talk about the non-foliated metamorphic rocks. And the two main ones, there are lots, and this is true for all the rocks that we've talked about. We're just talking about the main ones, all for igneous, sedimentary, and metamorphic. But the main two kinds of non-foliated metamorphic rocks are marble, which is metamorphosed limestone. So when limestone is exposed to high heat, remember limestone is a sedimentary rock. When that's exposed to high heat and pressure, it becomes marble. And you know about marble too, right? Marble countertop, marble statue, marble columns of a Greek temple, right? You know about marble. And then the other one is quartzite, which is metamorphosed sandstone. And you know about sandstone, right? Sandstone we talked about in the sedimentary lesson. Sandstone is composed of sand-sized grains. And when that's exposed to high heat and pressure, it becomes something called quartzite. And you probably, have you heard the word quartzite before? I would be kind of surprised if you had, but you've definitely seen quartzite because the that pink rock out there that I can see right from here that makes up the track, that crushed pink rock, the same stuff, the black rock that makes up the railroad ballast by the railroad tracks, that's quartzite. You don't think about it all the time, but that type of rock is called quartzite, and it's a metamorphic rock. Do you have questions about the types of metamorphic rock? Let me make sure. Okay, so here we got some rocks. So the first one we're going to look at is, this is a piece of shale. Look at, we've seen this shale in a previous time. Oh, get out of the way, mouse. Oh, whatever. Look, it's got layers. Shale. And then this one is slate. So I don't know if you can actually tell on video the difference between those, but this one's certainly darker. But here, look. Let me point it this way at my desk so that I'm not pointing it at. Get out of the way, coffee. Here's how you tell apart. Are you all listening to? Here's how you tell apart shale and slate. They look very similar, don't they? And they even kind of feel similar. One thing is you can get this wet. You can get them both wet, and this one will smell like dirt, and this one won't smell like dirt because it's been metamorphosed. Some people lick it. Don't lick these, right? But some people, like out in the wild doing geology, will just lick them both, and then, oh yeah, it's shale. Well, they'll only have one example, right? They'll just want to know if it's shale or slate, and so they'll lick it, and they'll be like, oh yeah, it smells like dirt. That's shale. Anyway, but a better way is if you got something hard, you can drop them both. This one, slate goes clink, and shale goes clunk. Ready? You hear low grade of metamorphism to high. So the one that started out was no metamorphism, right? Shale has not been metamorphosed, just lithified. Then slate. So next we're going to look at phyllite. This one's phyllite. The reason they get shiny, which they do, is because shale is made out of minerals that like fit together. Like they're flat minerals. We call them platy minerals, and they fit together in like a line, and they all line up. And the slate forms when they get even more squished together by heat and pressure. And then when they line up enough, they start to get shiny because their planes of cleavage start to reflect the light more. So the phyllite is shiny. Followed by, this is schist. This schist has, I don't know if you can see it, these little like pimples on it are garnet. So this is the mineral garnet that has, it was at one time phyllite, is continually squished. The minerals that make, or the atoms that make up the mineral garnet start to sequester out by partial, kind of like fractional crystallization. So that's schist. And then eventually they line up. This is not a perfect example of gneiss. Some gneiss you can find, it looks almost just like a piece of zebra flesh because it's like perfectly striped white and black. But effectively, when the metamorphism gets high enough, all of the light-colored minerals separate into layers different from the dark-colored minerals, and it makes this banded effect. The other two that we have here, well, two metamorphic rocks, is this quartzite. Quartzite, kind of rough feeling, which came from this sandstone. We looked at the sandstone the other day. But the sandstone under metamorphism becomes the quartzite. So this is sandstone. You can feel the difference between them. In general, the metamorphic rocks will feel, maybe not smoother, but like, I don't know, tighter. Metamorphic rocks are almost always denser than sedimentary rocks because they've been squished. And then the final one, I have two samples of this, but these are both marble. and these have come from limestone like this one. Marble. So, how did you remember how we said we could tell the limestone from sandstone if we had to? We talked about this the other day. What could we do in the wild to see if something's limestone or sandstone? What was it?
Gross.
What was it? Sorry, you said it.
I said grain size, but.
They can have similar grain sizes.
Hydrochloric acid.
Hydrochloric acid, right? The limestone will bubble in hydrochloric acid. Marble will a little bit, but only if you really like. If you chip off a piece of marble and get it really almost powdered, it will react with hydrochloric acid. But as a rock, it's tight enough packed that it really doesn't react. It's so smooth. Also, if you have a marble countertop at your house, please don't put hydrochloric acid on it because eventually it will eat away at it. In fact, that's why things like marble tombstones and marble Greek temples and stuff are really affected by acid rain. Is because they're made out of something that reacts with acid. Is that everything you might ask yourself? I think we're good. Bye.